Okay, so the next question that we have on the menu today is asking us the fraction 1 over 24 can be written as the following sum. 1 over 24 is equal to 1/8 of x plus 1/4 of y plus 1/3 of z, and that's all equal to 1/24. Okay, seems reasonable, and it gives us a system of equations or multiple equations that are related to each other, and they tell us the numbers that could occupy x, y, and z. So we know that x plus y plus z is equal to 1. 2x minus y plus z got to be 0. And we have negative x plus 2y plus 2z is equal to negative 1. Okay, so this is a system of equations, and essentially what we're going to try to do is we're going to try to solve for x, y, and z, and then that should definitely give us and this top expression here should ring true once we solve for the x, y, and z just with the bottom three. Okay, so let's write out our system of equations. So we have x plus y plus z is equal to 1. Let's call this equation A. Equation B, we have 2x minus y plus z is equal to 0. And equation C, we got negative x plus 2y plus 2z is equal to negative 1. Okay, there are many different ways that we can solve a system of equations. The method that I'm going to proceed with is going to be probably the most straightforward. We're just going to do repetitive isolate and plug. So I'll call this the isolate and plug technique. Other options include matrix, math. Some calculators are even powerful enough to do this matrix math for you, but that gets into it's a little bit more difficult and more delicate, but this isolate and plug technique that I'm about to use should be fairly straightforward. Okay, so what we're going to try to do is we're going to take equation A and we're going to isolate one of the variables. So let's say we try to isolate, actually let's do equation B because we have equals 0 on the other side. So that's going to be a little bit easier to deal with. So equation B, we want to isolate one of the variables. In this case, let's isolate y. So here we have 2x minus y plus z is equal to 0. We could rewrite this by bringing y to the right hand side, and we'll have 2x plus z. 2x plus z is equal to y. Okay, and it's good to square these off. Now we want to sub this into one of the other equations. So sub into another equation. Let's do sub into A. Okay, so we know that equation A originally is x plus y plus z is equal to 1. Okay, so this y we're going to replace with this. So it's going to be x plus, instead of y, we know that 2x plus z is equal to y, and that is plus z itself is equal to positive 1. Okay, so that's all cool. So let's simplify. So we have 3x plus 2z is equal to 1. Now we want to follow the same procedure again. So we want to isolate one of the variables. So let's isolate x. Isolate x. So to do that, we'll have to bring the 2z to the other side and divide both sides by 3. So we'll have x is equal to 1/3 of 2, whoops, it's got to be negative. So it's going to be 1 minus 2z. Okay, and that's going to be our x value. Awesome. And given this, we can sub into final equation. In this case, our final equation is C. Equation C. So equation C, we have negative x plus 2y plus 2z is equal to -1. So we want to replace y out of here like that. So we can rewrite this as -x plus 2. Now the y is multiplied by 2, so what we equate it to also needs to be multiplied by 2. So it's going to be 2x plus z, because that was equal to y, plus 2z is equal to -1. Okay, so we can expand this out to be 3x plus 4z is equal to -1. And that's just by doing 2 times 2x minus x. That's going to be 4 minus 1x, so 3x. And then 2z plus 2z, 4z minus 1. And the x is here. We're trying to isolate this. Substitute x. And we know that x is going to be 3 times 1/3 of 1 minus 2z plus 4z is equal to -1. I'm sorry for the Americans who are hearing me right now say Z for the last letter in the alphabet. I'm from Canada, so Canada we say the letter Z. I know Americans like to say Z, but I'm sorry. Please accept me. Okay, so you can see the 3 on the outside and the 1/3 here. They neutralize. So they become 1. So let's give them a little x out. So all that we are left with is 1 minus 2z is plus 4z is equal to -1. And combining all of our like terms, we have 2z, because that's the 4z minus 2z, and then bring the 1 to the other side, it becomes negative, so we have -2. So z has to be -1. Okay, so we found one of the numbers. That's beautiful. Now that we have this number, z equals -1. I'll do a different color so it's more clear. We can go back up to here, and we sub that back in. So x is equal to 1/3 times 1 minus 2 times -1, because that was z. So x is going to be equal to 1/3 inside the bracket, 2 times -1. That's going to be 1 plus 2. So that's going to be, as a result, 3 in here, and then x has to be 1. Okay, now that we know x and z, well, equation A can pretty quickly tell us what y is going to be. So if we know that x plus y plus z is equal to 1, we could have used any of the equations here, but this was just like the one that was right in front of me and the most convenient. So we know that x has to be 1 plus y. Y is, well, we don't know y, but z, we know that we have -1. That's equal to 1. Hey, this cancels out with that, so y is equal to 1. Okay, so this will be the result of our system of equations analysis. So x, y, z. x is 1, y is 1, z is -1. Hopefully we would come to the same conclusion here. Z -1, y is 1, x is 1. Awesome. And yeah, so that means now that we found these, and the original question was asking us like 1/24 is equal to x over 8 plus y over 4 plus z over 3. Now I want to sub these in to check if this is going to be actually well, true or not. 1/24. So x is equal to 1, so 1/8, plus y is 1, so 1/4, plus -1, which is z over 3. And we want to make all of, to make this true, let's take the right hand side and make them all denominator 24. All, you know, squiggly over 24. So this will be 1/24 is equal to 24 is 3 times 8, so what, 24 plus 6/24, because 6 times 4 is going to be 24, minus 8/24, right? Because 8 times 3 is 24. Now that all of them have the same denominators, we could see that we have 3 plus 6 minus 8. So that's 9 minus 8. That's 1/24. So 1/24 equals 1/24 equals big happy face, because that means that we have definitely solved, we have correctly identified x, y, and z, found their real values, and subbing it back in. With this system of equations, everyone is satisfied. You sub in x equals 1, y equals 1, z equals -1 to any one of these 4 equations, and everything's good. So yeah, this solution is awesome. We came to that same conclusion of x, y, and z, and we proved that it's got to be good. The golden rule here is that the number of equations has to be greater than or equal to the number of unknowns, or the number of variables. And this must be true to be solvable. Must be true to be solvable. If that is not true, you can't solve it. You can only have like you'll have equations for like one variable is a function of another variable. So yeah, assuming this is true, everything else will be solvable and everything else will be good. So yeah, cool. So the above solution is good. Beautiful. Good job. High five.